So today we're going to finish up sort of the first component of the course. The first component of the course, this course in some sense works on two levels. We first sort of introduce the basics of supply and demand, how you use them, what you do with them, them as a fundamental economic tool. Then we're going to go back starting next lecture, and we're going to get underneath what creates the supply and demand curves based on the principles of individual utility maximization and firm profit maximization. But today we'll finish up the supply and demand section of the course, and we'll do so by talking about the shapes of supply and demand curves. The shapes. Now, we've talked so far about supply and demand curves and what they are and what shifts them and what happens when they shift. But that's all been qualitative. It's all been, well, demand falls or price rises. It hasn't been quantitative. It hasn't been talking about, well, how much does price rise or how much does quantity fall when there's a shock to demand and supply. To understand that, we need to think much more about the shapes of the underlying demand and supply curves. Okay? So what we're going to do is start with some illustrative examples and then talk about a general understanding of what drives the shapes of these curves. So let's consider two extreme examples of a supply shift. Okay? So we've got in figure 3.1, we're back to our boring pork market, and we've got a standard market equilibrium. We start in equilibrium at point E1. That's where demand equals supply, where all the trades that make people happy are being made. There's then a drought. That leads to an inward supply shift because the price of hogs rises. So suppliers need to get more for their pork in order to justify selling it. So there's that inward shift, and that leads to a higher price and a lower quantity of pork being sold, and new equilibrium. Okay, and we talked last time about how you get there. Now, let's imagine that the demand curve looked differently. In particular, let's turn to the case of what we call perfectly inelastic demand in figure 3.2. Perfectly inelastic demand. So figure 3.2 is perfectly inelastic. What do I mean by that? Well, think about what the word means. It means it does not change. Inelastic demands means demand is not at all sensitive to price. Inelastic means insensitive to price. Okay? So the demand curve in that situation is perfectly vertical. The quantity demanded is going to be the same at any price. And we call that an perfectly inelastic demand curve. Now in this case, what happens when there's a supply shift? Well, now when the price of hogs rises and suppliers need a higher price, they're going to sell the same quantity as before. And they're just going to raise the price by exactly the amount the supply curve shifted up. So it's not going to be this back and forth compromise between suppliers and demanders in terms of where the price ends up. Basically, demanders have no say because they're going to buy Q no matter what. Suppliers get to say, fine, the price of hogs went up, so we're just going to raise our price by the amount the price of hogs went up. Okay? Now, so that's what's going to happen in this case. Now, whoops. Now, when is demand likely to be perfectly inelastic? Yeah?
Life-saving drugs.
Life-saving drugs, but more general. That's a good example. More generally. Yeah? Well, that's not going to be as inelastic, but I'm not going to present an example. What's the general principle under which? Yeah?
Something that consumers are going to buy the same amount no matter what.
No matter what, because there's no what? There's no substitute. Something with no substitute is going to be, so life-saving gasoline is somewhat inelastic because there's not great substitutes, but you can walk or ride a bike. Insulin, there's not a great substitute, okay? Because you take it or you die if you're diabetic. So perfectly inelastic demand is going to be something where there's no substitute. And once again, in general with these things, I want you to understand good examples like insulin, but remember the underlying principle as well. That's why I like getting answers which are examples, but also answers which are more general, which are the because that more general answer will let you figure out the class of goods. Now, once again, no goods are ever perfectly inelastic. People could decide to suffer or something and not take their insulin. But it's about degrees. Perfectly inelastic is sort of extreme. Now let's go to the other extreme in figure 3.3. Let's go to the case of perfectly elastic demand. Perfectly elastic demand. Perfectly elastic demand is a little bit harder to understand, but it's demand where people are willing to pay a given price. And that's all they'll pay. And if you charge 1 cent more than that price, they won't buy anything. And if you charge 1 cent less, I'm sorry, if you charge 1 cent more, they won't buy anything. If you charge 1 cent less, they'll buy an infinite amount. So essentially, you can think of this is hard to think of as a market. It's more easy to think about it as a firm. Okay? It's hard to think about a market where if the price 1 penny less, people buy an infinite amount. But it's more to think about sort of a firm. Think about, for example, a fast food restaurant. Okay? In a group with a bunch of other fast food restaurants that are equivalent. If they try to charge a little bit more than the other restaurants, people can just go next door and get the same crap. Okay? If they charge a little bit less, everyone will come to them. So that's perfectly elastic demand. A bit harder to think about, but it's basically a situation where people are very, very price sensitive. Now in that case, imagine pork was this way. Imagine people were pretty much indifferent between pork and beef. People are really indifferent. Imagine they sat side by side at the supermarket. Well, in that case, what happens when the price of hogs rises? Well, the pork producer says, I want to raise my prices. But he can't. Because if he raises his prices 1 penny, nobody buys. They all shift to beef. So what he has to do is to keep his prices the same, which means quantity falls a lot. Okay? So in the perfectly inelastic case, quantity didn't change, price went up a lot. Here, price doesn't change, quantity falls a lot. Okay? So basically, and this is going to be the case, perfectly inelastic is the case with no substitutes. Perfectly elastic case is going to be with perfect substitutes. More generally, we'll be between these cases. More generally, what will define the shape of any curve, the shape of the demand curve, will be what we call the price elasticity of demand. So it's going to define the shape of the demand curve. It's going to be the price elasticity of demand, okay, which we're going to call epsilon, which is going to be delta Q over Q over delta P over P. Okay? Now, we're going to go back and forth between continuous and real, between deltas and derivatives here. And once again, we're going to be a bit loose about that. Technically, it's really the derivative of Q with respect to P. But it'll be easier to think about sometimes as actual percentage changes because we're going to work with discrete numbers here, not with continuous intervals. Okay? So if you think about it in terms of discrete numbers, it's the percentage change in Q over the percentage change in P is the elasticity of demand. So basically, if for every 1% increase in price, the quantity purchased falls by 2%, that'd be elasticity of demand of -2. Now, based on everything we've seen about demand curves so far through the first 3 lectures, what restriction do you think we can put on this elasticity of demand? Based on what we've seen about demand curves so far, what restriction can we put in the elasticity of demand? It's non-positive. Okay, we just saw a case where it's 0. But it's basically non-positive. Okay? 0 would be inelastic. Okay? Now, we'll talk about cases later on where that's not necessarily true, but by and large, that's a rule we'll impose this semester, is that it's non-positive. Perfectly inelastic demand will be epsilon equal to 0. That is, doesn't matter, quantity doesn't change no matter the price. Perfectly elastic demand will be epsilon equal to -infinity, which is a tiny change in the price has an infinite effect on quantity. Okay? So this is sort of the general formula you need to keep in mind when we're thinking about price elasticity. We're thinking about the shape of a demand curve. Now, likewise, this is the elasticity of demand. There's also an elasticity of supply, which is how the quantity supplied changes when the price changes. That will typically be positive. Okay? This is saying when the price gets higher, consumers want less. How rapidly they want less is the slope of the demand curve. Okay? And that's the elasticity of demand. The other side of the equation, as the price goes up, providers want to provide more. How rapidly they want to provide more is the slope of the supply curve, and that would be the elasticity of supply. Okay? So it's the same principle on both sides of this scissors of demand and supply. All right? Questions about that?